Hello guys, this is ʟɪᴛᴜᴜ. As I have promised to you, I am online now. So I was a bit late in this 6:30 show due to some unavoidable reasons because I have some other classes to take as well. But this is also my responsibility to come in this live session as well. So as soon as you can, you you may please join this session so that I can start with this. So please do join this session. And if I am audible, then please please be please confirm that whether I am audible or not. Then if my audio is reaching to you or not, let me confirm that. Okay, if anyone is there, whether my audio is reaching towards you or not, please write in the comment section. Live chat is open now. You are free to comment over there. Live chat is open now. You are free to comment over there. So please do comments. Please do comments if I am audible, whether I am audible or not. I'm not getting sure of that. Today I'm going to start the last session, uh, of this rotational motion. Not the last, but till now it will be the last one. But I will try to continue with that as well. But my today's motto is to cover most of the things, mostly depending on the MCQs as well. But the thing is that if you require another queries, another much more discussion, then I may come up with certain things. But I'm going to wrap up this session on rotational motion, and the class 11 based revision chapters will come with some new type of study, with some new type of uh, new new chapters, right? So without wasting much more time, let us start with today's session. तो पहले ही हम लोग क्या करते हैं कि सवाल ले लेते हैं. So before taking the first question, I would like to request all of you, whoever is seeing my channel, please do subscribe this channel. Your one subscription will encourage me a lot to make such videos of tutorials of physics with much more dedication, with much more effort, right? So I will be very happy to be among your choices. So please subscribe my channel and give your encouragement as well, right? I'm not getting the vibes that whether this is reaching to the correct person or not. So If I am audible, please share among your friends and relatives and whoever is in need in such classes, right? Okay, so let me check the visibility in different platforms, then I'm going to start this. uh, I'm going to start it very soon. Please be with me. The new session on this, the new session on rotational motion, right? So please be with me. Your one subscription will encourage me a lot regarding bringing the new videos, new live sessions as well. This channel I have dedicated to the students who are aspiring for different kind of entrance exams as well. So please do like this channel and subscribe. If you like this channel, if you like my teaching methods, if you like my theory of sharing, then please do like this channel. I am going to start the session very soon. Within a few minutes, I'm going to start my session. Please do like my subscribe. Your one subscription can make the difference in creating more videos like this, right? Yes, hello. If you have any queries, you can put in the live chat section. right? Okay, so let's start today's session with our first question, which is coming up with, I think now the first question is visible to you. The question is asking that an annular ring with inner radius and outer radius, uh, outer radius of R1 and R2 are rolling with without slipping with a uniform angular speed. The ratio of forces experienced by the two particles situated on the inner and the outer ring. So with this question we left is the last live session. So this was the live session where we left. So the question is asking for an annular ring, right? Annular ring is there, and there is a inner radius and a outer radius for the same, right? Annular ring is there, there is a outer radius and a inner radius, right? So our matter of concern is, to find the ratio of F1 by F2. So the force F1, that is inner radius, has been uh, given as R1 and outer radius has been given as R2. So the whole thing, if we are going to find out F1 by F2, that will be the ratio of centrifugal force, that is m omega square R1 by m omega square R2. M and omega, that is the mass and the angular velocity, will be same for the annular ring, because we are taking the same ring, right? So with this context we can say that this is becoming F1 by F2 is becoming R1 by R2. So this will be the answer of the given question. So among the four given options, you can see that option A will be your right choice. Option A will be your right choice, right? So option A will be your right choice. So let us do another more thing. Okay, just let me change the visuality so that you can find it a bit more informative one, right? It is visible correctly. Okay, so if you have any queries regarding the questions, regarding any kind of queries you have, you may put it in the comment section as well, right? So let us go to the next question, right? So the next question is waiting for you, that is going to be this, right? I am telling you repeatedly, please do subscribe this channel and please encourage with your subscription, your comments, your queries, whatever you have, in the subscription is totally free. Your interaction is absolutely highly, your interaction will be highly encouraged from my side as well. So please keep watching, and your constant participation always encourage me a lot in this regard, right? So I think you can see the question right now. Right. If you have any queries, you may ask in the comment section. Okay. So the question is asking that a mass of 100 gram is tied to one end of a string of 2 meter long. The body is revolving in a horizontal circle. The body is revolving in a horizontal circle, making a maximum of 200 revolution per minute. The other ends of the circle is fixed at the center of revolution, and it has been already told that the maximum tension on the string can be bear is approximately what? So we have to find out the tension. So you have to keep certain things in mind very clearly whenever you are solving such problem, that this is a problem of horizontal circular motion, right? This is a problem of horizontal circular motion, right? So in case of horizontal circular motion, whenever, if this is a horizontal plane, horizontal means इस प्लेन के हिसाब से चल रहा है, इस प्लेन के हिसाब से, ऐसे नहीं. मान लीजिए ऐसे एक धागे को ऐसे उंगली में फंसा के और एक ऑब्जेक्ट को ले लिया, उसको ऐसे घुमा रहे हैं. So that is going to be the horizontal circular motion, right? So considering this horizontal circular motion, we can expect that the tension experienced by the say this is the center and this is the thread, right? So the tension will be in this direction. I think it is visible. If not, I am going to draw it with another ink. This is the horizontal circular motion. It is going round about this, and this is the axis of rotation, right? Now the thread is being tied in this manner, right? The object is here. The thread is being tied in this manner. So the tension is working here. Here it is the tension which is associated with this rotational motion, right? Now what you have to understand, you have to understand that in case of horizontal motion, the tension is the force, that is the centripetal force. So the tension experienced is equal to the m omega square r. And what is this r? R is the radius of this center, right? So omega is given as 200 revolutions per minute, 200 revolutions per minute. So RPM is given, that is 200 revolution, but we have to convert it into, omega is given as 200 RPM, but we have to convert it in RPS by simply dividing it as 60, right? So then it will become RPM. RPS, revolutions per second, right? And this is going to be this is going to be this is going to be the revolution. Then we will find it as R, since R is not given over, okay, the end of the string is 2 meter long, right? 2 meter long is there, so R is also given, and we can put it as so putting all the values of M as 100 gram and omega square as 200 by 60 square and R is as 2 meter, and since it is 100 gram we can take it as 10 to the power minus 3 divided by 10 to the power minus 3 will be there, right? So it will become 87.8 Newton, right? So among the four given options, let us see, among the four given option D is going to be the correct choice for your question. Look at this solution once again, right? So for the given question, option D will be your correct choice, right? If you have any queries, any question, you may ask over here, right? If you have any queries, you may ask over here. Am I audible or not? If I am getting inaudible, then please do notify me whether I am audible or not. If I am not audible, please do notify me. Okay. So let's move on to the next level of class, and I must say, for the kind, with the gracious blessings of Sri Thakur Anukul Chandra and Satsang, the group admin of Satsang Medical Association has invited me to post my lectures in their group with uttermost respect, and I am wholeheartedly encouraged, I am wholeheartedly enthusiastic about this invitation, and I am very much, I feel obliged to Mr. Dr. Ashim Kumar Dhar and Satsang Medical Association for admiring my lectures and gave me the privilege to post my lectures in that group also. And I must take the privilege to thank Bardhan Private Tutor Association for allowing me to maintaining the live stream session on their group as well. Right. Thank you to all my admirers and all my viewers. I must thank to all of them. I just want to convey that please encourage me. Your one subscription is going to encourage me a lot, right? So please do encourage me, and your encouragement will be always highly appreciated, will be highly appreciated by myself. So this was the last questions, and so before going to the next question, let us discuss some other thing that is related to certain theory of different driving forces are there, certain theory of some comments I have received regarding projectile motion, and I am also I have thought about that to take a dedicated live session on projectile motion only. So lot of things are going on inside my mind, and I am going to take that very seriously. But before taking a dedicated session on projectile motion, it is possible, let me check whether it is possible or not for me to carry out the session with with other important chapters and topics as well. So with that commitment of doing future lives in a very more efficient manner, let's take our next question. Right. So the next question is going to be from the section of IIT screening test. That now I would like to spare more time to the viewers who are watching my live sessions to read the question very carefully, that a child is standing with folded hands at the center of a platform rotating about its central axis. The kinetic energy of the system is K. The child is now stretched his arms, so that moment of inertia of the system doubles. Now the child is now stretches his arms, and the moment of inertia becomes doubles. The kinetic energy of the system now is what? Four options are given: 2k, k by 2, k by 4, 4k. Right. You can see from here the questions as well. To all my viewers, a humble request to please subscribe this session, subscribe this channel, and so that you can get the opportunity, get the privilege to have informed about the future live sessions as well. So the question is all about this is also a question from the topic of horizontal rotation, right? So the child was initially standing in a simple pose or of which on a platform which was rotating about its axis, and at that moment the kinetic energy was K. right? So the kinetic energy, the kinetic energy initially, initially it was k, right? And let's say the initial moment of inertia, say I1, and if the table was rotating about its axis initially with omega 1, then it would be omega 1, and the final velocity, final angular velocity, I am taking it as omega 2, and final moment of inertia as I2. So from the conservation law of momentum, angular momentum, conservation law of angular momentum, we can say that I1 omega 1 is equal to I2 omega 2. We can say that, right? Now it is also can be conferred from the given equations that this I1 omega 1 and I2 omega 2 has another relationship of getting doubled, because I1 omega 1, we can write it as twice of I1 omega 1, right? Because it was getting doubled, this I2 omega 2 was getting doubled, right? So because moment of inertia was getting doubled, right? So from here, this is not going to be omega 1, this will be omega 2, just the I1 will change, right? So from this equation, another equation is coming out, that is omega 2 is becoming omega 1 by 2, right? That means what? That means the final angular velocity is half of the initial angular velocity, and that is the reason that the moment of inertia is getting doubled, right? Now what is the, let us see the formula of rotational, the formula of rotational kinetic energy. What is that? Rotational kinetic energy. Rotational kinetic energy was half I omega square. So initially it was half I1 omega 1 square, initial rotational kinetic energy, and again the final rotational kinetic energy, final rotational kinetic energy is becoming what? Half I2 omega 2 square, right? Half I2 omega 2 square, right? We have the privilege of I1, I2 equal to 2I1, I2 equal to twice of I1. We have the equation, we have this equation, this equation, this equation with us, right? And essentially the initial rotational kinetic energy has been already termed as K in our question of concern. Okay. Okay, just a minute, there may be some technical glitch over there. Just a moment. There may be some technical. I think the technical issues are over now. The platform is visible, I think. So as I, right? If you have any queries, any question, you can put in the comment section. You can put in the comment section all your queries, your questions. I will be highly encouraged with your comments, with your subscription to my channel. Please do subscribe for future updates on this. So we were discussing this problem. We were discussing the problem on this, right? Now this, in the first case the child was standing still, and in the second case the child was standing with some stretched hands, right? So by doing this math we have come over here, right? So let us complete it first, then we'll have a short chat on it. Okay, so this is becoming what? Half I2 omega 2 square is becoming, we have I2 equal to 2I1 half into 2I1, right? And omega 2 equal to omega 1 by 2, right? So omega 1 by omega 1 square by 4. I have just squared the term, right? Omega 1 square by 4. So this 2 is getting cancelled out, but there is again, we can write this as half 1 by 2 I1 omega 1 square divided by 2. We can write this. This 4 we have divided it. So this is basically becoming what? This is basically becoming the initial kinetic energy by 2. So this is the problem where by doubling the I, the kinetic energy is getting half, right? So let us see the question, given question over here. So among the 4 given options for this question, you can easily identify that option B will be the right choice for your question, right? To my all dear viewers, I would like to convey my hearty regards and wishes for the coming new year, and stay with me, be a part of this live session. Your one subscription and sharing with more friends is going to make a lot of success to this live stream. So if you have any queries, any questions related to this session, You may ask in the comment section. Right. So this is a very interesting section where we discuss different problems, different solutions as well, how to tackle such problems as well. Now, from this problem, let's move on to a very common problem which has come in JEE main, that the angle turned by a body undergoing circular motion depends on time as theta equal to theta naught plus theta 1 t plus theta 2 t square. Then the angular acceleration of the body is, it is very easier one. You don't need to do much more complex type of calculation for this, right? It is very easier one. If anyone is there, please write the correct option over here. I will be highly encouraged with your interaction, and I would like to request all of you to subscribe this channel. Your subscription can make the difference to my effort, right? So please do subscribe this channel. If you have any queries, any questions related to this session or any kind of thing, you may ask in the comment section as well. I'll be happy to answer your queries. So this is a simple question. You are watching on your slides on your screen. So an expression related to angular displacement. Theta is nothing but the angular displacement of a body, right? So let's change the view first. So the angular displacement, that is theta, is given as theta naught plus theta 1 t plus theta 2 t square, right? Now it has been asked the angular acceleration. So first find the angular velocity. Angular velocity omega equal to d theta dt, and that is going to be what? That is going to be theta naught, derivative of constant is going to be 0, theta 1 will be there, dt of t will be 1 and plus 2 theta 2, right? 2 theta 2 t, importantly. Now the angular acceleration. Angular acceleration is given as alpha, which is d omega dt. That can be derived as d dt of this expression omega is this, and ddt of this expression. So again it is constant, so it is 0, and 2 equal to dt of t. So 2 will be only there. So the acceleration is our coefficient. It is calculated as 2 equal to 2. Right. I beg your pardon for the technical glitch is taking place. Please allow me to check that for a moment. I am getting back to you very soon. Some technical glitch is taking place. Okay, sorry for the inconvenience. So the answer, so let's see the question again so that you get the idea of that. So on the given question, you can see that this the among the four given options, you can easily that option D, option D will be your right choice for this question. Right. Option D will be your right choice for this question. So there is a problem with the camera, I think, uh, due to some technical glitch is there. Uh, just allow me to fix that up to some extent. Now let us, I would like to request all of you to subscribe the channel, and let me check the camera for a while. I'm getting back to you very soon. আইপিটা চেঞ্জ করলে ভালো হতো। আরে ঠিক করো, লাইভে দেখাচ্ছে। কেন এরকম হচ্ছে ঠিক বুঝতে পারছি না। কাইন্ড অফ প্রবলেম ইজ গোয়িং অন। Don't know. Okay, I think now it is clear. Now the technical glitch has been removed, I think. Okay, thank you for your patience. So let's continue the class. So I was discussing about this question, right? So this is the option D will be the correct option. Now let's move on to the next question, which is asking about some other thing, that is asking for sorry, excuse me, it is a very cold time. Okay, so the question you are watching, it is asking about three identical spheres which are kept aligned, right? So सभी कुछ कहने से पहले मेरा एक निवेदन है आप सभी से कि जितना भी हो सके ज्यादा से ज्यादा आप लोगों का सब्सक्रिप्शन मुझे बहुत जरूरत है। आप लोगों का सब्सक्रिप्शन मुझे इनकरेज करेगा कि अगले टाइम ये ऐसे ही और सारा इंफॉर्मेटिव वीडियोस लाने के लिए। सो व्हाट एक्चुअली डू दैट, जितना भी हो सके आपसे, जितना भी हो सके ये जितना भी हो सके please do share among your peers, and please uh, do visit this channel again and again. And if you want to get informed about the live sessions as well, you will get the information only after getting subscribed to this channel, right? So let's move on to this question. The question is actually asking regarding the three identical spheres which are actually aligned and each of mass 1 kg, each of mass 1 kg, right? And they are touching each other as it is shown in the figure, right? So if with the center of on the straight line, right, if their centers are marked as P, Q and R respectively, the distance of the center of mass of the system from P is the distance of the center of mass of this system. So whenever we are taking certain spheres of our concern, right? So there are basically three spheres. फियर नहीं है, डर नहीं है, डर वाला फियर नहीं है, ये स्फीयर है. So three spheres are there whose centers are aligned, right? Whose centers are aligned in a straight line like this. So this is the x-axis and this is the y-axis. I think I should enlarge this screen so that it is visible to all of you. Now it is visible to all of you. So for this, let us change the light setting a bit, because दोनों से क्या हुआ कि ये जो है आपको दिखाई नहीं पड़ेगा अगर हमने थोड़ा इसका लाइट सेटिंग को चेंज नहीं किया, क्योंकि ये लाइट थोड़ा गड़बड़ी का है, ठीक है, जिसमें हड़बड़ी हो जाएगा. ओके Okay, now it is visible clearly. Okay, you can interact with me in the live chat as well. There is an option of live chatting over there. You can interact with me in the live chat as well. So let me make it very clear from the given question. So ये तीनों जो स्फीयर है इसका जो सेंटर्स है, जैसे कि वो लोगों ने नाम दिया है इसका P, इसका Q एंड इसका R. तो ये बोला गया है कि ये जो सिस्टम है ये पिक्चर में थोड़ा गलती है, ये किसी ने नोट नहीं किया होगा. द गलती इज व्हाट with the other two spheres. The galti is all the spheres are touching each other, right? All the spheres are touching each other. ठंडे का टाइम है, एकदम सटा के बैठे हैं, है ना, ऐसे टच करके बैठे हैं, ठीक है. So this is be like this, a little bit modification of the representation, but this is Q and this is R. So there must be a center of mass. So let us find the center of mass, position of the center of mass. So X center of mass will only be found by each of having 1 kg of mass, each of having 1 kg of mass. हर एक फ्रेम जैसे जरूरी होता है ऐसे स्फीयर का भी जरूरत है, और दोनों का मास बिल्कुल है 1, दोनों का मास बिल्कुल है 1, right? So now the thing is like that we have to do over here 1 into 0 with respect to P I am taking. Next is 1 into PQ. This length we am taking. M1 x1 plus M2 x2 plus M3 x3 PR will be there, right? PR will be there, right? Divided by what? M1 plus M2 plus M3. सेंटर ऑफ मास का फॉर्मूला है ये M1 x1. सेंटर ऑफ मास क्या है? M1 x1 प्लस M2 x2 प्लस M3 x3 डिवाइडेड बाय M1 प्लस M2 प्लस M3. ये आ गया x ऑफ COM. अब y ऑफ COM तभी आएगा, ये इधर पे तो ये वर्टिकल वाला सिस्टम नहीं है, ये हॉरिजॉन्टल सिस्टम है, तो इसका सेंटर ऑफ मास भी यहीं पे होगा हॉरिजॉन्टल वाला. तो फिर इसका सेंटर ऑफ मास क्या होगा? तो आंसर हम लोगों का आ रहा है PQ प्लस PR बाई 3. PQ प्लस PR बाय 3. ये हो गया आंसर PQ प्लस PR बाई 3. तो चलिए देखते हैं वो क्वेश्चन क्या था, और क्वेश्चन से देखने से हम लोगों का ऑप्शन के बारे में भी पता चल जाएगा. PQ प्लस PR बाई 3. तो क्वेश्चन में जो दिया हुआ है उससे आ रहा है कि क्वेश्चन नंबर बी विल बी द करेक्ट चॉइस. क्वेश्चन नंबर बी विल बी द करेक्ट चॉइस फॉर योर क्वेश्चन. क्वेश्चन नंबर ऑप्शन नंबर बी, not question number B, it will be option number B, right? So option B will be your correct choice, right? To all my viewers, it is a humble request to make subscribe of this channel and share as much as you can. Your one subscription is going to encourage me a lot more, like that. So please do subscribe the channel, and I humbly convey my regards to Baron Private Tutor Association and Satsang Medical Association for allowing me to share my life on their pages, respective pages. Right. And hold your breath for a moment. I will be right back. Just I'm there for a moment. Please be with me. I will be right back. So, okay, guys, welcome back, and let's take the next question. That is another question from the topic of center of mass. The question is asking that two masses m1 and m2 are connected by massless flexible and inextensible string passed over a massless frictionless pulley. The acceleration of the acceleration of the center of mass, the acceleration of the center of mass, right? यहाँ पे आप देख सकते हैं कि जो क्वेश्चन दिए गए हुए है वो है कि दो मास है जिसका मासेस है m1 and m2 there which are connected by some inextensible pulley, inextensible string, and those are massless, flexible and inextensible string passed over massless and frictionless pulley. The acceleration of the center of mass is what? Four options are given. So to solve this problem, we have to look after a little bit back. right? To solve this problem, the same question has been asked regarding the problem. So let us solve the problem. So the problem is telling that जो कि मास है, हम लोग ऐसे कर सकते हैं कि फोर्स इक्वेशन लिख सकते हैं, मास 1 प्लस मास 2 इंटू ए सेंटर ऑफ मास, जो कि सेंटर ऑफ मास का एक्सेलरेशन है, वो m1 a माइनस m1 m2 a है कि नहीं, है ना? तो फिर ये जो ACM है, मतलब कि सेंटर ऑफ मास का जो एक्सेलरेशन है, वो किसके साथ इक्वल होगा? वो इक्वल होगा m1 माइनस m2 बाय m1 प्लस m2 into a, right? Now m1 minus m2 into m1 plus m2 into a. Now this a can be written as you can see the situation. There is a massless and frictionless pulley is there. Consider this case, right? Along which the threads has been passed, like say this is m1 and this is okay, let's take this as m2, this takes say m1. Okay, so this is the direction of movement A and the pulley is moving in this direction. So we are taking this consideration of this m1a minus a in this direction, so m2a, right? So a is also in the direction of G, right? So m1 minus m2a, so we can write this as m1 minus m2, so downward it is working m1g over here and here it is working m2g, right? So the change in calculation will be m1 minus m2 by m1 plus m2 is getting multiplied with another m1 minus m2 by m1 plus m2 into g. Now as a whole they are becoming m1 minus m2 by m1 plus m2 whole square into g, right? So this becomes the acceleration of this center of mass. So let us see the options. So this becomes the ACM, acceleration for the center of mass. So let us see the four options. So among the four given options, you can easily see that option A will be your correct choice. Option A will be your correct choice, right? If you have any question, you can put in the comment section as well. Your comments will encourage me a lot, and your subscription will help me to bring much more live sessions and much more interactive new kind of sessions with you, right? So without spending much more time, let's take a simple kind of problem which is of relevant to some vector related problems, that is, you can see on your screen. No, you can't see. Let me show you. Yes, now it is visible. Am I right? Now the problem is visible to you, right? Your comments, I will get the idea of my orientation of teaching, that which chapter you require. Please do mention in your comments so that you can get the advantage of that, right? I am going to take new chapters in near future, and the session will only be concentrated on that chapter only, right? So yes, tomorrow will be the session will be a Sunday evening session. Sunday evening, late more, a bit late. It will start a bit late. That will be from, I will let you know accordingly. Yes, any other question? Okay, so before starting this session, let me go back to the question first. So the question is telling that a force is there, a force of Fk minus Fk acts on origin O. The origin of the coordinate of the system is coordinate system. The torque about the point 1 comma minus 1. The torque about the point 1 comma minus 1. The force is minus Fk cap, minus Fk cap. right? The force is minus F K cap. Okay. So we have to understand that, right? You write the question and let me draw the scenario first. X-axis, Y-axis and Z-axis is there, right? Now the force is can be given as like this. Let's take this as F force and let's consider the point P somewhere here. This is point P. So the direction vector will be working towards center. This is the center O, right? So direction vector will be working in this direction. So this the coordinate of point P is minus 1 comma 1, right? And F is given as minus F K cap. So the torque about this point P, the torque will be, this is the arm and the force. We know that torque is given by force, couple force into couple arm, right? Couple force into couple arm. Couple force is given as minus F K cap and couple arm is given as PO cross PO, right? So PO is basically from the coordinate of P, we can write it actually minus Fk cap cross minus 1 comma minus 1. So for that we can write minus I cap plus J cap, right? So it is going to be minus Fj cap minus Fj cap, because I cap cross K cap will be minus Fj cap, right? And minus F K cap cross J cap will be minus F I cap, right? So by rearrange this, we can write this torque as taking minus F common, I cap plus J cap, right? Now let us see among the given options over here. which will be the most appropriate one, right? So among the given options, you can see from this that among the given option, the right option will be minus f, that is minus f I cap plus j cap, that is option D will be your right choice, right? So with this question, I am drawing end to this live session, and if you have any comments, if you have any doubts sustained with you, please do comment me, and if you still have some queries, some physics related questions, some issues during your regarding your coming up entrance, like that, it is all your suggestions, depending on which I am going to take uh, certain decision on regarding the carrying on the future live sessions. And if you really do like this session, please do subscribe this channel and give a big like, share among your friends, share among your near and dears. And I'm going to make live tomorrow evening. It will be not, certainly it will be not a 6:30 classic show, as I do. 6:30 classic show will be available for Monday. It maybe Monday will be there. Tuesday is not a 6:30 classic show. It will be some other show. I will let you know. And most importantly, it will be another time show. I will let you know. So please do with me, like the channel, be with me as much as you can, and do subscribe my channel. So that's all for today. This is with Prakash Das, your physics tutor, signing off for today. Bye bye.